Yeah, I'll do a quick intro. So yeah, hi everyone. Thanks for joining us. My name is Bob from the Academic Services side of ECEE, and we're discussing senior design in our Pathway seminar this week. I'll go ahead and keep admitting people if you don't mind. Uh, just to please leave yourself on mute unless you have a question to ask, just because you're getting a little bit of background noise every now and then. But we're going to start with one of our lead senior design faculty members, Dr. James Aberly, and we'll also hear from Dr. Jennifer Blaine Christian about interesting opportunities for your senior design projects too. So Dr. Aberly, it's all you now. Thanks.
Okay, thank you, Bob. So welcome to the Pathways on Senior Design. I know that many of you are probably pretty curious about the senior design sequence. As you hopefully know, they are designated in our program by EEE 488 and EEE 489. And one thing that I want to begin with is just to point out to you that the capstone sequence, I'm going to share my screen here, that EEE 488 and EEE 489 are quite different than most of the other courses that you've taken in the EE program. So what do you do in most of the other courses? Well, you attend some lectures, you might do some practice problems in a recitation session, you work on homework, you take exams, and all of the problems that you work on are very well defined and they are closed. So there's, a right or wrong answer. But it turns out that in the real engineering world, most problems are not closed in that way. Oftentimes there's no right or wrong, there's just better or worse solutions to a particular problem. And the problems that you have to solve are not just, what's the value of the resistor you need in the circuit? They are multidimensional in the sense that they incorporate factors other than just the basic theoretical frameworks that you learn about in a lot of your undergraduate classes. They include factors like economics, manufacturability, and the like. So in order to help you to prepare for the real world of engineering, we offer a capstone course. And this isn't unique to ASU. Capstone courses are ubiquitous in engineering programs, and they are really required by the accreditation board to allow our program to be accredited. If your electrical engineering program were not accredited, then it really wouldn't have any value in the world. Accredited engineering programs are a must, and the accreditation board kind of determines a lot of the content that we're expected to cover. It's a group of professionals who understand what real world engineering is about and place requirements on programs. So the key is that EEE 488 and 489 are very different from other courses in the electrical engineering program. And I've described to you what most other courses involve. In fact, there's usually just one instructor to whom you must answer. But in EEE 488 and 489, you need to apply engineering principles for many different classes. And in fact, you need to learn new things. So for example, you need to learn things about soft engineering considerations. And by soft, what we mean is there's no right or wrong answer here. There's just better or worse. So manufacturability, economic factors, et cetera, come into play. And another thing is that it's more like the real world of engineering, where you're going to work in teams on an open-ended project, where even the project definition and goals may evolve over time. So for example, you may start out with a very ambitious idea about what you're going to have at the end of your senior design course sequence, and then come to realize that some of these goals are not realizable within the framework of senior design. And so you'll have to modify your project definition and goals. And you work under the guidance of a technical mentor. in many cases, this is an electrical engineering program faculty member, but not always. There are other, you can work for a technical mentor who's a faculty member in another program. You can work for a technical mentor who is working in industry. And in fact, one of the things that I've been doing a lot of lately is co-mentoring with industry mentors. So I have currently 4 projects, 1 finishing up in 489 and 3 in 488, where I am not mentoring the team alone. I am mentoring them in conjunction with someone who's working in industry and has an interest in the project that the students are working on. And that for me seems to be an ideal situation. Now, in addition to answering to your technical mentor, you also have to answer to the course coordinator. And I am one of 2 electrical engineering faculty members who serve as course coordinators for EEE 488 and 489. The other one would be Professor Kazicki. And I do the spring, fall, and Kazicki does the fall, spring. And so our capstone sequences are 180 degrees out of phase. In any case, my contingent of 489, the one I'm coordinating, is finishing up in December. On December 4th, they will have their final showcase, and it will be together with other engineering programs in Fulton, and it will be a virtual event, and all of you, and basically everyone is invited to attend, and you can take a look at the projects and see what they've accomplished, and maybe understand a little bit better about what expectations you should have going into senior design. And a lot of the work in the capstone sequence is writing reports and making oral presentations. So we don't have any tests per se. There's a couple of quizzes about some of the lecture material, which is basically on the soft engineering issues and entrepreneurship, customer discovery, and the like. But most of the work is writing reports and making oral presentations. And this is an extremely important skill for engineering students to learn how to be effective at, because you spend a lot, it's been said, I don't think anyone knows who originally started this saying, but it's very, very true, which is, it doesn't matter what you do. It really doesn't matter what you do unless you tell other people about what you do in an effective way. So learning how to write effective reports and making effective and convincing oral presentations is an important skill. And one of the goals of our capstone sequence is to help you to become proficient at doing that. So as I hope you know, EEE 488 and 489 are a 2-semester capstone project sequence. And once you enroll in EEE 488 and start working in a team, you must enroll in EEE 489 in the subsequent semester, working in the same team. If you don't take 489 after 488 for some reason, then you have to start the whole sequence over again. There's no exceptions to that. So in EEE 488, what do? You form teams, you select projects and mentors, and you plan, research, and carry out the design phase of the project, and also the documentation, the written reports, the oral presentations. In 489, the plan you developed in 488 is executed, evaluated, and improved, and then you document your work in a final report, and then the project is presented to the public. So it's very important that, one of the things that I have to make sure our industry partners understand is that the work that you do in the capstone course you must have at least some part of that you can present to the public. Yes, you can work on things that are protected, say under a non-disclosure agreement with a company. So there may be some information that is disclosed to you on the project that you cannot disclose to the public. But ultimately, you must have something that you can display to the public to show them, the wonderful work that you did in the capstone sequence. So Again, let's talk a little bit about the teams. Teams must consist of 3 or 4 members. Actually, this slide is a little bit dated. We've gone ahead and allowed 3, 4, or 5 members. And basically the teams form on an ad hoc basis. You connect with each other, and it's the same with the projects and selection of the mentors. I will be, at the beginning of 488, I typically ask our faculty and industry partners as well. And one of our best industry partners is General Dynamics. I want to give them a shout out because some of they've always been involved with our capstone sequence. Some of the students that worked on General Dynamics projects ended up working for General Dynamics and are now mentoring projects of their own. So I have colleagues working at General Dynamics who took the capstone sequence with me a number of years ago and are now themselves mentoring projects. And of course, that's a really ideal situation because they know what the expectations are. So again, the formation of the teams and the selection of projects and mentors is done on pretty much an ad hoc basis. I will ask the electrical engineering faculty and industry contacts for project descriptions. I'll make those available to the students, and then the students can reach out and determine whether or not they want to select those projects. It's also possible for students to come up with their own ideas and or to have an existing relationship, say with a faculty member, and then ask that faculty member to develop a project for them that they can work with others on. So again, it's very important. You can't work on your own capstone project. Almost every semester I get asked, I want to work on this project by myself. That's not how it goes. The project has to be substantial enough that it requires multiple students to be working on it. And it's also an important skill to learn how to play well with others. So we try to work on that as well. And as I mentioned, the team does remain intact for both EEE 488 and 489. So be careful to choose wisely when you form a team. You want to work on a project that you're going to enjoy with a mentor who pays sufficient attention to the team, and with team members who are going to pull their own weight. And one of the I've had to deal with situations where teams were formed on the basis of friendships, and those friendships did not survive the capstone sequence. So you need to be careful about that, and you need to learn how to deal with conflict. There's always going to be conflict. There's always going to be different ideas about how the team should move forward, different ideas about how things should be done. And this is something you need to learn how to deal with effectively, because that's life. So again, the coursework is mainly done in teams. There are a few individual assignments just to hold accountability. And then there's a peer review at the end of each of the 2 semesters. And this enforces individual accountability for team performance. So if you're not pulling your weight, your grade will be lowered. So you need to be aware of that. So many times I hear about complaints from senior design teams that so-and-so is not pulling their weight, and they've been doing this since ASU 101. Well, by the time students reach 488 and 489, maybe they're more self-confident or whatever, and they don't really tolerate it. So you can expect that you will have to pull your weight. And if someone's not pulling their weight, you need to confront that individual. And if you require assistance in dealing with the situation, then I can help. Again, I'm not a trained social worker or psychiatrist, but I'll do my best. And of course, the main thing is attend all the meetings, right? If you're not showing up for meetings with your mentor's not going to know that you're doing anything. Participate without dominating in team discussions, take responsibility for various tasks, complete your work on time, treat your teammates with respect, okay? You're going to be, the real world today is you're encountering people from a variety of different backgrounds, a variety of different socioeconomic circumstances, diversity across various dimensions. So you have to learn how to deal with that situation and treat your teammates with respect, etc. The project mentor is usually an EE faculty member, but not always. And each group is required to find and work with a mentor. You do need a mentor in order to help you, and in particular to define the project goals and scope. And if you hit a sticking point, to help you over that. One of the important things to realize is the mentor is not there to solve every problem for you. They are there to give you guidance where you can find out how to solve the problems. And one important thing that I want to emphasize in senior design and in your life as engineers in general is you're always going to have to learn new things. You can't expect that, you can't, when you get a job and you get an assignment and you encounter something that you haven't seen in your coursework, you can't tell your boss, well, I can't work on this because I haven't seen it in my coursework. That's just not going to fly. So you do need to and expect to learn how to do new things. So I think I will stop talking now and open it up to any questions on this.
Yeah, Dr. Avely, I'll help you with a couple good questions that came up in the chat. So one is from Melvin, and he's asking, is the, sorry, my chat just moved. I had it right in front of me and then is the individual accountability weights decided between team members, or do we express our views to our mentor?
Actually, you can express your views to your mentor, but mostly I am the one making that decision. So I review the peer reviews at the end of the semester, and based on the numerical the numbers that people report in terms of contribution, as well as the comments, I will make a determination about whether a grade should be lowered or not.
Okay, thank you. And then Newton is asking about a question about interdisciplinary teams. So do team members need to be electrical engineering majors? What if you'd like to work on an interdisciplinary multiple major program?
Yes. So because of the way academia is structured, your team must comprise electrical engineering students, and you must complete the electrical engineering, the work of EEE 488 and 489. However, we have had situations where a team of electrical engineering students fulfilling their own requirements is working together with a team of students from another engineering discipline. And so things like, there might be a common elements to reports and things like that, but as you might expect, the requirements in the EEE capstone sequence, there might be different timing of reports, different content requirements, etc. So the answer is you can work in interdisciplinary teams, but it has to be arranged in a way that facilitates the accountability to each of the courses that the students are registered for. Thank you.
And then to add to that, we do have students on these interdisciplinary IDEA teams, but it's very important that all team members have support from their individual schools, like if it's a mechanical student and electrical, that sort of thing. That needs to be worked out ahead of time. Eric is asking, is there a platform to express project area interests amongst students?
Yes.
Yeah.
Yes. So at the beginning of the semester, so it is tied to the beginning of the semester. There's nothing ahead of time. Although I typically ask that the learning management system for 488 open up a little bit earlier. And then there will be Piazza and a special forum on Piazza for connecting, with students and project ideas.
Okay, and then I think you mentioned a little bit about this, but Min Liang is asking about mentorship. How do you find mentors, or how do students find mentors if they're doing it on their own?
Yeah, so there's any number of ways that students can find mentors. I think for most students, what would happen is at the beginning of the semester, or just before the beginning of the semester, I ask the electrical engineering faculty as well as industry contacts if they have any project ideas. And then I will post descriptions of these project ideas on the learning management system. And that will allow students to reach out to each other, not only each other, but also potential faculty member advisors or potential advisors, whether they be faculty or industry. So a lot of times what happens with me is I have an industry contact and I ask them, would you ever be interested in mentoring a capstone project? And in several situations, they've said yes, and I've worked with them on developing a project description, and I'm the co-mentor along with that industry person or that company, and then the company, maybe the CEO of the company who I talk to appoints one of their underlings to be the advisor. So it can happen in a number of different ways, but the most common way is by looking at the project descriptions. Or, I may get a general statement from a professor saying, hey, I'm willing to work with students who are interested in this area. And then you can go contact that professor and negotiate with them about a specific project.
Thanks very much. And some of the students were expecting Dr. Blaine Christian today, and I think she's had something come up. So I'm going to briefly explain what she was going to discuss, because it was in context of a really cool project that might get your ideas going. But she was going, and she's an engineering faculty member who's very interested in the concept of universal design. And universal design, help me if I'm saying this right, Dr. Aberle, but it's generally the design and kind of construction of an environment, product, service, all of the above that's not an accommodation, but kind of keeping all users, all people who interface with it in the design concept. Is that a good description?
So
Dr.
I'm very embarrassed to say I don't actually know what.
Okay, I think I did it. So someone else could, so I think I got it.
And I think that I was very interested to hear Professor Blaine Christian's talk so I could learn about universal design and then maybe disseminate that to the students. So, but that sounds good. That sounds good.
Yeah, that's it. And I have a little bit of experience with it just in my personal life, but projects that are kind of projects that use this concept are encouraged, and they're very valuable to your futures, and they could kind of put you off on an interesting career path if you're so inclined. I know one group that kind of took this, that was mentored by Dr. Blaine Christian last semester, was they designed a prosthetic hand that was that won. We have a kind of an award every year that has a small financial reward to the students involved. And the prosthetic hand project, which is all electrical engineering students, about how to develop a hand that works well, that moves the way we want it to move, that sort of thing. So she did that. Other universal design concepts might be, I know Dr. Blaine Christian, I don't want to speak too much to what she does, but she's working with people with different sort of intellectual disabilities, and designing things, products, services, environments that aren't necessarily just accommodating people, but actually, actively involving them in the design, so that it works as well for everybody. That sort of concept. So it's a really cool thing, and she's we're sorry she couldn't be here today to talk about it more. But if you have questions about it, you can we'll put her some information in the chat in just a moment on how you could reach her if you're curious about doing that as part of your senior design project or in life in general. Now back to Dr. Aberle, if you have a couple more minutes. It looks like we have a question from Curry. Do most project ideas originate from students, or the other way around, from faculty and mentors?
Mostly from faculty and mentors. The majority are from faculty and mentors, or some sort of co-development.
Okay, and then are the varied disciplines centered mostly on the pathways themselves, or can they be more refined? How related can the EE disciplines be between group members? Does that?
Yeah, so it really depends on the scope of the project. If it's a situation where there's, I've been involved with teams that had students whose pathways were more related to electromagnetics, working with power students because they needed to have some power electronics that was involved in the project, as well as the, an antenna or a low noise amplifier or something like that. So, or DSP, right? A student that's a signals and systems area might be working with somebody in electromagnetics, for example. So it really depends on the nature of the project. It depends on the student's particular interests. It's all very ad hoc. It's, there's not really a recipe that we follow. It's, it really is, every situation has elements that are, unique to that situation.
Great, thanks. And then Celine is asking us, with regards to the final project, the physical project, how does that work for online students in different locations? If we decided to create a machine, does each person create a part of this machine? Does it need to be simulated as well? We have a lot of successful online groups. What do you have to say about that?
We do have a lot of successful online groups. I have a group of students that are currently finishing up in 489, and they are working on a reflector antenna with a feed. One of the students in California has his own 3D printer and is printing doing some prototyping with their own 3D printer, but then sending things to the ASU 3D printer that another student who's local here is picking up. And then, so, the reflector needs to be metallized, but the 3D printer prints out plastic. So this student is using a conductive paint to make it conductive. And then another student is in the Virginia area, is working on, other aspects of the project, the motor driver, for example. And so this is, again, a situation where we have students that in different areas, power and electromagnetics specifically. So yes, again, it's not, there's no particular formula that you would follow. It's something that you got to work out on the basis of the individual team. Who's got what facilities at their, that they can utilize. If you have, students with a 3D printer, it doesn't matter where they are, they can print out scale models perhaps of something and then send it to the ASU printer once it's been verified.
Yeah, and I think we even had some teams where there's a mix of Tempe and online students on the same project. Is that correct?
Yes, this is the project that I mentioned is that as well. Yeah,
Yeah,
two local students and two students, one in Virginia, one in California.
yeah, and I might add that many engineering firms are, as most of us, we're working more remotely, and I think that might even be an expectation for your future, that you're going to have to be working on cross country and maybe even cross the world projects. So,
yes, and by the way, the company that's sponsoring this is in Tucson, so they're not even local here. So, and they are, so when things need to be shipped, that company will use their FedEx account or whatever to ship stuff from from Amazon to the student or whatever.
Those are great questions. While we have Dr. Egerly here, are there other questions like that? These are very good ones. Thanks.
Yeah, so I want to emphasize again that there is no particular, fixed set of rules that you have to follow in making the projects work, in terms of collaboration. This is something that, we can assist you with. We have certain sets of tools, Slack, Piazza, et cetera, that you can use to collaborate, but students are also, figuring a lot of stuff out. And a lot of it depends on the nature of the individual project.
Yeah, and I would say if you want a good follow-up to this, the best way for you to get more information would be to attend the Pathways seminar live on the 4th. So December 4th, a student already asked this, but we will share with you.
Yeah, that's the capstone showcase, not a Pathways, right? Capstone.
I'm sorry, thank you for clarifying. Yeah, the capstone showcase itself. So for the students in 489 right now, we're going to be presenting the project they worked on for a year. And we will share that link with you very shortly through the same means you got this link. You can see live projects, you can judge them yourself, you can decide what you think should be the winner, just have some fun with it, and see what your fellow students who are in senior design now came up with, and maybe that'll drum up some ideas for you.
Yeah, I think too that, you know, and you can ask the students that are presenting their projects how they overcame certain barriers as well. You know, so one of the things I should mention is there are hundreds of students in senior design. So unfortunately, I don't get to have a lot of personal contact except with the teams that I am personally mentoring. I have 3 20-hour TAs, and the TAs do a lot of the heavy lifting in that class, the grading of the reports, the answering of students' questions and things like that. So one of the things that you'll find, and I have great TAs, the TAs that are really go above and beyond for the students. And I hope that that will continue into the future. Bob, I just saw another question come in. Stephen.
Oh, yeah, there we go. So of all the projects you have seen, how many students had to improvise their initial plans due to complexity?
Yeah, so I think almost all the projects, that the project scope and goals evolve over time. Yes, and in some cases they've actually added stuff to the project because things went more smoothly. But most of the time it's the other way. They actually have to you know, reduce the scope of the project.
Yeah, thank you. Is there and Celine is asking, is there a specific ASU mentor, EC, or electrical engineering faculty advisor that deals with prosthetics who I can get into contact with? I believe that would be probably Dr. Blaine Christian. Is that correct?
Yeah.
Yeah. If someone, it's hard, I don't have my double monitor. If someone doesn't mind putting her faculty bio into the chat, that would, yeah, thank you.
Yeah. And let me tell you, you don't have to wait till the semester begins. If you have ideas for a project and you want to reach out to a professor, go ahead. I mean, there's no rule against it. You know, I would be very shocked if any professor would you know, be upset that you contacted them now for a project that was starting, say, in the spring.
Yeah, to get ideas. So,
you know, for sure you can, if there's a professor that you know, enjoyed their class and want to work with them, reach out to them. It's not a problem. You know, the worst they could say is, no, I'm too busy or something.
yeah, so, and we have a lot of support. You can have these conversations with your peers too. You can have them with your current faculty, get ideas going now. Any other questions while we still have Dr. Aberle with us? It was a very good Q&A and a great presentation. Thank you, Dr. Aberle.
There's one more from Eric.
Oh, I got 2 now. So same question as Celine's, but more for power electronics.
On it.
So that was
So Lynn's already answered that.
I put in the link to our website that has the faculty specifically interested in electric power and energy systems. You're able to search by keyword on here, and we do have it broken out by subcategories. And we do have this for all of our areas of specialization on our website under the research header at the very top of the page. So we have our faculty organized by general subcategory, but there's a lot of flow between the areas. So don't limit yourself and look at all of them.
Yeah. And I see that, did another question come in? Gabe?
Yeah, an online student is verifying that this is a session C full semester.
Only session C, only session C. Yeah.
Always, yeah.
No quarters. It's both are session C, and the online and the on-campus students are together, and they can form teams, hybrid teams, you know, that are some online, some on campus.
And just really quick too, it's fall, spring, or spring, fall, everybody. There's no summer.
Yeah, thank you. And to back up what Lynn was saying, it's I recommend everybody, regardless of where you're at in the degree now, just read the faculty bios. I think it's just engaging, even if you're early, if we have some freshmen in the group now, just to know what these folks are doing. They have interesting backgrounds, interesting ideas, and it might lead you to read a word you didn't know about, and that might end up being something you want to specialize in. So please read the faculty bios. We put them there specifically so you can learn not more about how to make contacts, but just what these people do.
Aiden is asking a question, and it's a good one. So if you do spring fall, so that would be my section that I, you know, my coordination of that spring fall. Yeah, it's a good question. Typically students do some work over the summer. It's entirely voluntary. It can be a source of friction if there are, say, 2 students in the group who do a lot of work over the summer and 2 who don't, because they have, you know, internships or whatever. So it's something that we work out on, and, you know, each individual team will work out whether they want to and can do anything over the summer. The team that I worked with, that's in 489 now, they did work over the summer. I did meet with them over the summer. You know, they seemed to be very happy with you know, what they were able to do together as a team.
I think the only follow-up there is, do you see a benefit spring, fall, fall, spring? Usually you wouldn't be doing it by that. Usually you're picking when you want to graduate, but do you see a benefit, Dr. Aberly?
You know, it may well be that if you can work over the summer, that spring, fall gives you more time to work on the project. On the other hand, you know, the fall, spring, it's, you know, it's over more quickly. It's 9 months as opposed to 12.
Yeah, we would encourage you to graduate as soon as possible. That's our recommendation.
Yeah. You know, it's again, it may, you know, what benefit there is may depend on individual circumstances. There's no right or wrong answer there.
Great. I think we had a bunch of thank yous in there to you, Dr. Aberly. So thanks for your
Well, you're
presentation.
welcome. My pleasure. It's nice to chat with everybody, and yeah.
Cool. Well, I'll hang on the call for a moment, but I think we'll probably get some more thank yous. So thank you again. But we'll probably end the recording now. And if anybody has any individuals, I'll hang out if I can handle them. But thank you again, Dr. Aberly. I think you can get back to planning your finals week. How's that sound?
That's good.